Hi, MAPE students. Welcome to lecture 6.6 on nuclear energy. I am showing you right here a picture of a nuclear power plant with cooling towers. It's very important to know that what's coming out of the cooling towers is steam. It is not smoke. Nothing burns in nuclear power, which is really interesting and one of the really good things about nuclear. So what I like to say with this unit with energy is we have the good, the bad, and the ugly. That's the name of an old movie, and it's really appropriate for energy. So the good is renewables. That's very good for the environment. The bad is fossil fuels. So that was what you were just learning about. And what's coming up next is the good. Fossil fuels are bad. And nuclear is kind of ugly. It might be good, but there's some ugliness to it. So this one's really in between. It's non-renewable, but it's very powerful. So there's some gray areas with nuclear, and there's a lot of arguments for and against, and that's what you really need to know. So let's get going. So what is nuclear fission? Okay, so you have fission and fusion with nuclear. Fusion is when two atoms come together, and fission is when two atoms go apart. So when things break apart, the actual nucleus, get it? Nuclear, it's the nucleus of the atom. When the nucleus breaks, it lets off heat. That's what fission is. Fission with two S's, that is fission. So a neutron strikes a large atomic nucleus and it releases more neutrons and heat energy. And then in addition to the neutral, let me just go back here. Except for a second so you can see that. So additional neutrons release more energy in a chain reaction. So that should say chain reaction right there. Okay. And the place that you are writing this is on page 21 of your lecture packet. Okay. So what you have there is nuclear fission. Fission is the breaking. So a neutron strikes a large an atomic nucleus, and we're going to be talking about uranium-235 in particular. That's a certain isotope of uranium. And then it releases energy in a chain reaction. So that's what you're writing down there that I am covering up. Sorry, chain reaction. Okay, so write that down. And now we have a nuclear power plant. And what is being held right here is uranium. And uranium is radioactive, but the heat is given off when it goes through a chain reaction. So I'll talk to you about how this actually works in the power plant. So all that needs to happen for nuclear is for you to release the heat from the breaking of the uranium-235 nucleus. And so everything about nuclear is figuring out how to keep it safe. Okay, so it uses the heat from the nuclear fission to produce steam, which is the exact same thing that happens with coal. With coal, you burn it to release heat. So you want that heat. If you can get that heat in an organized way, then you can use it to boil steam, to turn a turbine. So it's the same inner workings as a coal-fired power plant. So 1 gram of uranium-235 contains 2 to 3 million times the energy of 1 gram of coal. So this is where uranium is a non-renewable resource. We will mine uranium out of the ground to get it, and we have to purify it into a more specific U-235, and I'll talk to you about that in a minute. So it is powerful. A gram of uranium-235 has 2 or 3 million times the energy of a gram of coal. All right. So it is powerful stuff. You don't need as much. So a typical pellet of uranium weighs about 7 grams, and it can generate as much energy as 3.5 barrels of oil or 17,000 cubic feet of gas or almost 2,000 pounds of coal. So it is condensed, powerful energy, right? So this is one of the reasons why sometimes you hear that we'll never run out of uranium because there's just so much of it. But when we use it, we do use it up, okay? So it is incredibly powerful. It will last for a long time, but it's still a non-renewable source of energy. So a nuclear reactor acts like this, okay? It is very similar to what happens in a steam reactor, except instead of putting the heat in here by burning coal, you use a reactor core to allow for the breaking of uranium's nucleus in an organized way so that it's safe, in a way that you can turn it on and turn it off. That's what's really important, okay? And then you create the steam to turn the turbine, which turns the generator, generate electricity. So this is going to be something that you're looking at in your energy study guide, okay? All right, so you have your reactor core, the fuel rods, the steam generator, the turbine, the generator, and the electricity, okay? So we'll be talking about each of these different things over and over and over again. So following along in your notes, these are the things that you're writing down on the picture that you can see there. Okay, so pause if you need a minute to write those things down. So the fuel rods are the tubes that contain the uranium pellets. Those are the fuel. So the fuel in this case is uranium-235, okay? So they're put together in a fuel rod and a fuel rod assembly, and that's what we call the fuel rods. So the control rods are inserted between the fuel rods and they absorb the excess neutrons. So this is what's going to keep it under control. So what you can do is you can have fuel rods and control rods. And if the fuel rods have the uranium, here, got the uranium. So the fuel rod has the uranium. And if you put control rods on either side, it slows down the reaction. Because the reaction is a bunch of, you can think of it as little ping pong balls flying all over the place. If they hit something, they'll break it and make more heat. So if you put a control rod in between the uranium, then it slows down, it absorbs. So it has neutron absorbing materials in it. That's all you really need to know for that. So a meltdown happens when the fuel rod becomes too hot and it actually melts. The water boils away and radioactivity is released. So that's the worst thing that can happen in a nuclear reactor, is that you can have a meltdown. And when we talk about meltdown, it's not just like melting ice, it's melting metal. This gets crazy hot, all right? So that is what you don't want. It can melt all the way through the chamber. And there's one time when this actually happened in history. So we'll talk about that. So yeah, so there's a problem. You can have a nuclear meltdown, which releases energy and lots of radioactivity and can cause all kinds of problems. So to get the uranium, you need to mine it. So 900 kilograms of ore, just the rock that you get out of the ground, can produce 3 kilograms of fuel. So you have to remove a lot of material to get the uranium. It's all the negatives of mining, except much less uranium is needed for the same amount of electricity. So you don't have to mine as much because the uranium is so much more intensely powerful. So it's not as bad as mining for coal, only because you don't need as much. So if you go back to your maps on page 10, you can annotate and make sure that you have the information. So we put the uranium on there already, like places where you put uranium in the map that I was showing you guys that was in green. So you can just like put a little bit more information on there if you want to. So to point out where there is a lot of uranium. And then that's going to go into our notes also, I think. Feel free to pause if you need a little bit more time. Okay. And please be writing down questions. You probably have some questions along the way. I'd be happy to answer those. All right. So, cool. So the location of uranium mines, you're going to write down Canada, South Africa, Namibia, Kazakhstan, and Australia. Okay. Okay, so Wyoming is a uranium mine that threatens the drinking water. So in Wyoming, they had some issues with the possibility. So this is the town of Gillette, where they are um, drilling for water, making wells, and they were concerned about the mine, the uranium mine, perhaps getting some contamination in the waterways. So you're writing that down, worried about contaminating waterways. All right. Okay, and so now we're going to go through advantages and disadvantages. Okay, so one advantage of nuclear, look at how awesome this is that sorry, these little things keep popping up. There are no emissions. It's so great. Nothing bad comes out of a nuclear power plant when everything's working correctly. No emissions, no CO2, no pollution at all. Now, if you have to mine the uranium, that's something to keep in mind, that you do have to mine the uranium, so there's pollution from the processing, but the use of it, just nothing. All right. So emissions from fossil fuels versus solar. So solar, you have to look at the whole with solar EV, the actual making of the solar panels has some emissions. But like nuclear, it's really, really low. So that is a great one. Very, very few emissions, like none. There's large scale energy production. It's predictable, and it's more predictable than wind or sun. Okay, because you can just have it. It could work at any time because you have it. That's the same good things from coal and oil. So this is a nuclear power plant in Belgium. Kind of a beautiful picture with the steam. Remember, so the only emissions are thermal pollution. Heat pollution comes off. But that's also happening in other kinds of power plants also. Because uranium is so efficient, it ends up having a little extra heat coming off, but it's not, and this is sort of confusing, but the idea of the thermal pollution from a nuclear power plant is that it's going to get hot, but it doesn't trap heat and keep it for a long time. So it's different than global warming. Okay, so it's like this, so if you go running, you get really hot and sweaty, and you just sweat and it cools you off, then you're not going to be hot for a really long period of time. What's different is global warming. Global warming is like going for a run with a parka on, a really thick jacket. And if you go for a run and then you want to cool down, you can't cool down because you got the big jacket on. And so you pass out and you die because you overheat. Sorry, that's an extreme example, but you can cool back off again. The heat that's dissipated from a nuclear power plant is not the kind of heat that sticks around forever. So it's just local warming is the only kind of issue that you have. All right, so disadvantages. You can have a nuclear accident. Where's the one? I don't know why I have disadvantage. I only have 2 and 3. Maybe the first disadvantage is that Homer works there. No. And then radioactive waste disposal, which I'm going to talk to you guys about in a minute. Where are you going to put the nuclear waste? Because the waste products are dangerous because they're radioactive and they're still hot. Like literally they're giving off temperature, but they're also radioactive. So there's 2 different ways to say hot. Hot is like if something has radioactivity coming off of it, you call that hot, even though it's not warm. But the breaking of the nucleus also gives off heat. So it's just important to be clear about that when you're talking about it. Okay, so here are some of the biggest nuclear accidents. The first one is 3 Mile Island in Pennsylvania. Okay, so in 1979 in the United States, a cooling water valve was closed, and the lack of cooling around the core led to a partial meltdown. 200,000 people were evacuated. Infant mortality and cancer rates may have increased, but that was pretty hard to measure. There were no known people harmed from the partial meltdown in Pennsylvania in 1979. However, the fear of there being a total meltdown was high. And we have not built a nuclear power plant in the United States since 1970. Okay, so this really concerned us. This made us very worried that we could just would destroy ourselves. Now, it is important to know that a nuclear power plant cannot explode like a bomb. What happens is it melts down, and what could explode is a like a steam explosion, like when you're boiling water for pasta and the lid blows off. That's the kind of thing that you can have an explosion, but it's not like a nuclear bomb. This is not high enough. It's not weapons grade uranium. It is electrical domestic grade uranium. Okay. Now, the second one is the big one. This is Chernobyl. And Chernobyl happened in 1986. So it happens at 1986 is when I graduated from high school. So this happened in our lifetime, my lifetime, not your lifetime. And so what happened was during a test, I disconnected a cooling system and removed control rods. The plant overheated and it led to a major explosion and a fire. This is where the wall blew off of the entire power plant in Chernobyl, Ukraine. 31 died at the time, and many had radiation exposure. The cancer deaths greatly increased. The wind blew and contaminated crops and milk. And this is something where I have a story about. I actually had a student whose name is Michaela, who was born without a leg because her mother was exposed to the radiation from Chernobyl. So this was quite a while back, but there was so much radiation in Chernobyl, even throughout the 90s, people were still being exposed to a lot of radiation. And her mother was exposed to radiation, and Michaela was born in the Ukraine. And she didn't have a leg. She had some misformed fingers and a little bit of problems with her eyes. But she was put up for adoption, and a family from Alameda adopted her. And she came here, and she was in my class, like 15 years back. And she was a really amazing person. She was a really fast swimmer. In fact, she was in the Paralympics. The Paralympics is for people who like either can't see or don't have a limb or something like that. It's very competitive. It's not the Special Olympics. It is serious Olympics for people with differing abilities. And so she was super fast swimmer just for Alameda High, but she was actually went to the Paralympics. She went to the Paralympics when it was in Greece. And I remember because she was like, she came to me and asked, like, can I still take this class if I'm not here the first week? And I'm like, what's going on? Why wouldn't you be here? And she's like, well, I'm going to be in the Paralympics. Like, what? And you couldn't even tell. She wore a brace for her leg, but if she was wearing pants, you couldn't see. And it was just really incredible to have a student in the classroom who was a victim from Chernobyl. This was a huge global issue, and 1986, I mean, really, that it did a lot to stop our use of nuclear. We do have much safer ways to make nuclear power, but it's very expensive to build a nuclear power plant. And so the new technologies that we could be using are just, there's such a, there's no political will to do this. This didn't help. This happened in 2011. This is the Fukushima disaster. And this was from an earthquake. So there was a 9.0 earthquake that triggered a 15-meter tsunami. And in Japan, so the tsunami comes over and just washes over the nuclear power plant. There's structural damage, interruption of power supply, fires, hydrogen gas explosion, the release of radioactive gases, and 4 of the 6 reactors were destroyed, and 100,000 people were evacuated. So this was a major disaster and happened much more recently. So it's just there's not a way to make it perfectly safe. Okay, and so there was traces of radiation in the ocean that you could even trace all the way across the Pacific. So it was everywhere. All right, so this is a video about Fukushima. So I think it might be hard for you guys to see this during my lecture. So I'd like you guys to go to this and click on it to watch it within the slideshow, or you could type it in. It's also, the URL is right here in your notes. Okay, so you're going to watch that. And then we'll talk about radioactive waste. Okay, so I'm going to stop right there and do the second half of this lecture in just a moment. See ya. Thanks for listening.